Let's get started. It's my privilege to welcome you to the University of Tennessee Nuclear Engineering Department Seminar Program. This is our last scheduled seminar for this semester, and I believe we might have saved the best for the last. Today's speaker is Dr. Buckner, who's from Savannah Riverside. Mel is a long-time friend of mine, a personal friend. In fact, he and I went to college together. We went to graduate school together. He's a three-time graduate of this department. Then we went to work at the same place. And after working there for 6 years, I left to go back to university. But he's been there for the past 31 years. He's had a very distinguished career at the Frazier site. He started out in computational methods development, which means he can do real good technical work. And now his title is Program Manager for University Relations and Senior Consultant for Site Integration and Program Development at the Savannah River Technology Center. Okay. His topic today is Global Nuclear Proliferation Management. It's indeed a pleasure for me to welcome old friends.
Good afternoon. I was concerned that we were going to start telling some stories, but fortunately we didn't, so I won't tell them. But it is good to be back on the UT campus. We've been here in a number of years. It's changed quite a bit, but it's still, I've never had trouble climbing up the hills. This afternoon, or this morning, I went over to Downey Hall and got windy just going to Downey Hall. I do want to talk about non-proliferation today, proliferation management. But I want to start out by giving you a brief description of the Savannah River site. I know many of you may be aware of the Savannah River site, but some of you may not be familiar with our history and where we are today, what we hope to be doing in the future. So I'm going to try to do that in about 5 to 7 minutes. So if you need a short nap, if you know all of this, just go ahead and take a snooze now. But the Savannah River site was built in the early 50s. The initial construction was authorized in 1950, and it was built in response to the Cold War, to concern with the Soviet threat of nuclear weapons. And the request came from President Truman to the DuPont company to build a site. At that time, it was the largest construction project ever undertaken. It used all of the stainless steel that was produced in the United States over a 2-year period from 1951 to 1953. The peak construction force was 40,000 workers, and the first reactor was started up in 3 years. Unbelievable in today's environment. But certainly, as we go forward in the new nuclear era, which I will talk about later, we need to get back to a time frame of maybe 5 years at least to build nuclear reactors if they're going to be competitive. The production mode spanned the period from 1955 to 1988, in which we operated 5 production reactors, 2 chemical separation facilities on a full-time basis. We separated our targets, discovered plutonium. We also produced tritium. We also recycled fuel for 40 years, very successfully. And certainly we'd like to see it start up again in the civilian program. We had a tritium processing facility, heavy water facility. We had everything contained on the Savannah River site that we required. This shows our location. We're on the border between South Carolina and Georgia, near Augusta, Georgia, and Aiken, South Carolina. A lot of people think of us as being in Savannah. We've actually had people come to visit the site and call us from Savannah and ask for directions. And we've had to tell them, well, you got to drive about 3 hours to get to the site. But we are pretty conveniently located to Atlanta as well as to Columbia, South Carolina. This shows 3 of the 5 reactors that we operate for many years. All these are shut down now and actually being used for other purposes. But the thing you will note here, is these reactors look different from commercial reactors. They were different. They were built for production to produce high neutron fluxes so that we can make nuclear materials. They were low temperature, low pressure reactors. We tried for many years to figure out a way to get a little energy out that we could utilize, but we were never able to do that. As I mentioned, all 5 reactors are now shut down. This is one of the canyon facilities, as they're called, chemical separation facility. We have 2 of these, one called F Canyon and the other H Canyon. And these facilities have operated for going on 50 years now to separate fuel and to recover various isotopes that were of interest to the government. To give you an idea of why it's called a canyon, is this what the facility looks like on the inside. It goes some 30 feet underground. This is a so-called piping gallery. No human has been in this area since the facility started up. Everything is remote. And the interesting thing is that the DuPont engineers, the various departments, they designed these facilities so well that they've operated all these years and probably will continue to operate it a number of years in the future. We don't know how many, because the Department of Energy continues to schedule the shutdowns. A continuing need that allows us to continue to operate the facility. In 1989, the world changed dramatically for the Savannah River site. One thing that changed was DuPont left the Westinghouse thing, so we have a different operating contract. But more so, our defense needs changed. Because the Berlin Wall came down, the Soviet bloc disbanded shortly after that, and our national defense role changed dramatically. Our missions now are stockpile stewardship, and that is to maintain the stockpile of nuclear weapons that are required for our deterrence capability. And of course, that is being discussed. We've had various START treaties. And President Bush would like to reduce the number of weapons down to maybe 1,500. It would be a really great thing if we can do that and have some assurance that that's adequate for deterrence. We continue to do tritium recycle. And as most of you are aware, tritium is radioactive. It decays at about a 12-year half-life. So we have to bring in the weapons from time to time and change out the tritium and purify that tritium to go back in other weapons. So we're still continuing to do that. We're also building a facility for recovery of tritium from the targets that will be irradiated in the PDA reactors. That will be the new way of producing tritium in this country. We have not had a source of tritium production since the late 80s, since our reactors shut down. We're also involved in nuclear material stewardship, particularly the disposition of weapons-grade plutonium. That's excess. It's been made excess by the retirement of these weapons, by reduction of the stockpile of weapons that we have in this country. And an agreement has been made with Russia to dispose of 50 metric tons of that material. And we have that mission at the Savannah River site. I'll talk about that a little more later. We're also involved in environmental stewardship, cleaning up the legacy of waste from the Cold War. We have over 40 million gallons of high-level waste on the site, stored in large tanks. Most of them are double-line tanks. But we're solidifying that waste, and I'll show you the facility that's used for that shortly. We're also remediating the site. We have a lot of waste areas, waste sites that have to be cleaned up before the site can be restored to the original condition. This is another facility, kind of looks like a canyon. It's built sort of like a canyon. Our architecture at Savannah River is not all like this. We do have some brick buildings that look a little more modern, but these are production facilities, and we don't waste any expense on them. They look nice. But this is the so-called Defense Waste Processing Facility. It started up in 1996 to solidify the high-level waste in borosilicate glass. Next slide shows the canisters that are used for this. In this process, the high-level waste is mixed with glass crit in a melter, glass melter. The waste is then poured into these canisters. The canisters are about 12 feet in height, about 2 feet in diameter, and once they're filled, they weigh about 11,000 pounds. We have made 1,200 of these canisters filled with high-level waste. To dispose of all of our waste, it will take over 6,000. So we've still got a ways to go. And we've been operating this facility since 1996. So our normal production of canisters is about 200 to 225 per year. Just to give you an idea of who's involved in the management of the facility, we are the Westinghouse Savannah River Company, and we manage the overall site. We have responsibility for a number of operations, including the Savannah River Technology Center, where I work. And the Savannah River Technology Center is the technology arm for the site. We do research and development, so we do little R, big D. We don't do a lot of basic research. Most of our research is directed at putting something into the field, and we've been very successful with that. We're also, Westinghouse Savannah River is also responsible for environmental safety and quality assurance programs and administrative functions. Bechtel is a partner. Bechtel does our design work and our project work, all the engineering and construction activities are under Bechtel. BWXT is a partner also in the operation. They're responsible for D&D, and the NFL is also on the site, and they have the solid waste management program. This shows you our technology base. We call it technical competence, degree of competence. We have some graduates from our technical competence organization at Ph.D. So you can see the kind of people we have at Savannah River. No, I'm just kidding. Ron was one of our real excellent guys, and we hated to lose him, even though I was at the University of Tennessee. This shows the mix of people that we have on the technical side. The site has about 13,000 people, so about half of those are technically trained. You can see the makeup, a lot of chemical engineers, chemists, mechanical engineers, and pretty good percentage of nuclear engineering and physics, some electrical, and other disciplines as well. Now I want to shift gears and talk about my topic. I am the chairman of an American Nuclear Society Committee. It's a special committee on nuclear non-proliferation, special committee of the ENS president. And I want to talk in terms of what we've been doing in regard to non-proliferation issues and kind of relate to you some of the thoughts we have. Our objective is to provide information to the technical community, and if I can use this for you. I guess I can't. Provide information to the technical community on issues related to non-proliferation. To develop public policy papers, and we have just completed a policy paper. We have just completed a policy paper that hopefully has been released by A&S this week. I've been on the road, so I haven't heard it. Thank you. And we are also trying to become, and have become, a resource on non-proliferation issues for the non-technical and policy community. I'm actually going to Washington tomorrow for a meeting. I think we will discuss a number of these issues with congressional staff members, with representatives from the State Department, from national laboratories, and various other officials who are involved in setting policy. And that's primarily what I'm talking about today, is policy. Not much technical, but just in the area of policy. So please understand that. In 1953, we really started early in the late 40s, 50s, started the nuclear era after it was determined that you could recover useful energy from nuclear generation. And Eisenhower was faced with many of the issues that we are today. Certainly a lot of things have changed since 1953. We have built around the country more than 400 nuclear reactors. So the situation is different, but a lot of the issues are the same. And Eisenhower had to deal with many of these issues, and the scale was really unbalanced. It was concerned about the effectiveness of deterrence, and that led to the Cold War and the build-up, the arms race, where we were trying to build more nuclear weapons than the Russians, and it led to the tremendous growth of the stockpile over the years. There was increasing concern with proliferation, with more countries developing nuclear programs. There was concern with the improper use of that technology and the spread of nuclear weapons. There were also emerging energy markets, and certainly that is much greater today. The environmental impacts were of concern, and the diminishing U.S. monopoly in this technology was a great concern. And I think it's even more so today, as our nuclear base has decreased over the last several years. We'll talk some more about that. Eisenhower's response was ask for peace, to work cooperatively with other countries in peaceful employment, peaceful use of nuclear energy and nuclear technology. Today, we have a different situation, but a lot of the same problems as I've already mentioned. There's concern that a lot of the developing countries have needs for energy if they're going to continue to develop and increase their standard of living. The electricity demands in developing countries is increasing at a level of about 4.4%. In China, that's about 5.7%. In the U.S., our energy demands are about 1.2, 1.5% increase over the next 20 years. If you look at it on a global basis, the number of gigawatts of new generating capacity is huge. It's like 3,000 nuclear plants. Size that we operate today. So the question becomes one of, if we're going to sustain the necessary economic growth and improvements in these underdeveloped countries. Where is the energy going to come from? How are we going to provide that energy? And if you look at the global picture, you see that coal is the dominant energy supply, natural gas, oil. These are not available in a great extent to the developing countries. They don't have those resources. Hydro, not a lot of hydro left, even around the world. There's some, but not tremendous amount. So you're kind of left with nuclear as being the option that is most likely to fill this need in the future. So we see a new nuclear era developing on a global basis. But let's think for a few moments about the trend in the U.S. The trend in the U.S. has been quite different over the last 10 years. Most of our nuclear materials production complex has been shut down. Now that's not a bad thing, but where it really impacts the industry is people, training people, and jobs. Provide the nuclear training that's necessary to support an industry at this time. There have been no new orders of nuclear plants since the late 70s. Although, you contrast that with the existing plants that are operating better than ever. And I'm sure you're aware of this. Last year, the average capacity factor for 103 plants in the United States was almost 90%. Unheard of 10, 15 years ago that we could achieve that kind of performance with these units. We're concerned with the core competency in the educational infrastructure that it is deteriorating in the United States. You're fortunate here at the University of Tennessee, still a nuclear program, and I'm proud of that. But a lot of the nuclear programs around the country have shut down. And I think some of you are probably aware that the number of university reactors has reduced from about 60 to now I think it's 24 operating in the United States. That's a concern. We don't have the educational infrastructure that will be necessary for the new nuclear era if we're going to take part in it. Also, we're concerned that in the foreseeable future, we may not have the legacy of skills really to participate in this new nuclear era. We're not going to have the trained people. We're not going to have the influence because our programs have dropped off. The amount of research money has dropped dramatically. That has changed a little bit over the last few years. With the NE program in the Department of Energy, the nuclear energy program, but there's still a long way to go. We're hopeful that that will continue to increase, but there's still a lot of constraints on the budget. Our main concern is that we will be unable to promote fuel cycle safety and ensure that civilian nuclear materials are not diverted to weapons use. They're always safe, secure, and legitimate to use. So our concern by my committee is that we approach this new nuclear era really using some of the things that People Energy has espoused over the last 5 years, some of the People Energy from New Mexico. Some of you may have read his speech that he gave at Harvard University, in which he laid out a program for changing some of the decisions that have been made in nuclear technology in 1997. One of the things that he said, which we really feel is very important, is that we need to recognize that the premises underpinning some of our nuclear policy decisions are wrong, and that we need to reevaluate those. And hopefully with the President's energy policy, be able to get back to it, will allow us to do that. Certainly, nuclear was given some part of the energy policy. It had a page or two in that big book that Cheney's committee developed. But at least it was in there. I'm hoping that that will give us some opportunities for the future. But in approaching the new nuclear era, we're concerned that we need to continue to emphasize that limiting the spread of nuclear weapons will be a major challenge in the 21st century for the U.S. and the world community. And that if we're going to have nuclear, a new era that really allows us to move forward with nuclear technology, that the civil program must continue to not contribute to the spread of nuclear weapons. Extremely important, and our Generation 4 criteria includes proliferation resistance as one of the objectives for the new design. So we see as the key to successful global proliferation management is U.S. leadership and collaboration with other countries. Well, let me just briefly run through the major points of the policy statement that I mentioned that ANS has adopted and has been released. There's several areas of concern that we tried to address. One of those relates to the peaceful uses of nuclear science and technology. The point there is that peaceful uses are compatible with the achievement of non-proliferation goals. We have demonstrated that over the last 50 years. There was a time early in the nuclear era, the first nuclear era, when there was a prediction that there might be 50 nuclear weapons states in the coming years. There are only 5 countries that are considered nuclear weapons states, and 3 that have the capability of nuclear capability. So we have been able to control this technology. Not perfectly. There are additional things that need to be done in this arena. But by and large, we have not seen the spread of weapons that we might have expected. The second point is that both extrinsic and intrinsic barriers are important to global non-proliferation. And this was pointed out recently in the so-called TOPS report, looking at proliferation resistance of new Generation 4 reactor concepts. The extrinsic barriers are those institutional type controls, such as IAEA would help in enforcement. The intrinsic barriers are those that we kind of design into the system to make the system proliferation resistant. And as I mentioned, that is a Generation 4 criteria. We feel that both closed and once true commercial nuclear fuel cycles actually fit under this umbrella. And that it's not necessary to maintain a once true fuel cycle to ensure proliferation resistance. The second area is dealing with new proliferation threats, that these must be dealt with, recognized, and dealt with quickly and through collaboration with both the industrialized and the developing nations, and certainly with established institutions such as IAEA. Why, you might ask, is this a U.S. imperative? Do we take on the role of the world top? And certainly, we don't necessarily take on that role, but we do have broad global responsibilities. We've had those over the years, and we tend to be a leader, and that has served us very well. We also have the largest nuclear weapons program at one time we did, along with the Russians. And we're also the largest producer of nuclear power generation in the world. The policy and actions really need to recognize legitimate constraints and concerns that are faced by other nations in addressing both energy and environmental issues, particularly from the point of view of resources and what is available for them to use for energy production. The last is a quote from Sam Nunn, that U.S. leadership is linked to the strength of its technical foundation. And we certainly endorse that. And certainly Sam Nunn has done a lot in the area of non-proliferation. He continues to do so, even though he's retired from the Senate. Existing proliferation threats are also a concern. These are ones that are already recognized and need to be dealt with. And we have had various groups who pointed these out, particularly the excess weapon plutonium and highly enriched uranium in the former Soviet Union. And of course, we're addressing that program, but we have a lot of concern that we're not dealing with that issue as expeditiously as we should. The National Academy of Science in 1994 pointed out these materials as a clear and present danger. Yet here we are almost in 2002, and we're still trying to decide how we're going to dispose of those materials. Well, we at Savannah River, as I mentioned, are very heavily involved in this activity. We're developing technology for we're developing, I saw something on the screen and it scared me. It was not me. It was something else. We're developing technology for disposal. The Department of Energy has decided to dispose of most of the weapons-grade material using MOX fuel and burning the material in light water reactors. There's also scrap material that has to be dealt with, and the decision there was to immobilize that material, place it in cans that are about 4 inches in diameter, about 18 inches high, and stack those cans in a defense waste glass canister, fill it with glass to provide the radiation barrier. The concern with that program, and you may be familiar with politics in South Carolina, there has been a lot of press in that regard, regarding the governor's concern that the Department of Energy has reneged on the immobilization portion of the program, because that budget has been cut to zero this year. And we are concerned that that program is not going to be carried forward, although the indication from the Department of Energy is it's been delayed. But the governor of South Carolina essentially made a deal with the Department of Energy that the plutonium from Rocky Flats would be accepted at Savannah River on the condition that there was an exit strategy. Right now, the governor is concerned that that exit strategy is in jeopardy. So he's essentially said, we're not going to accept plutonium shipments until you tell me exactly how you're going to dispose of this material. So there's been a disconnect there. More so, the Baker-Cutler report, which is a great card on our plutonium disposition program, expressed concerns that we were not moving fast enough, and we needed to supply more money, particularly so that the Soviet Union would move forward with their program. We're not so much concerned with the material in the United States. We'd like to dispose of that material. But the material in the Soviet Union is much less protected. The accountability is much different from ours. And I think particularly since September the 11th, there should be greater concern in that area of where these materials are and who can get access to them. And certainly, these programs are going to require substantial resources and really sustained and stable support by the U.S. government over the next several years. The next item that our policy addresses is the need for a strong domestic nuclear infrastructure. We need that infrastructure and that base of well-trained engineers and scientists to be able to continue as leaders in the world program, in the nuclear program, as it advances on a global basis. And it is advancing. Other countries are putting much more into research than we are. We're concerned with the current erosion of that technical base, that it threatens our influence and our leadership in the international community. We had a special session in San Diego a couple of years ago, and Dick Stratford, who is in the U.S. State Department, head of the non-proliferation effort there, I think captured our concern very well. He said that if we don't stay in the game in nuclear, we're going to have increasing problems making our points in the international forum. And more so beyond that, as having anyone listen to us. The last item that we try to deal with in the policy statement is related to proliferation-resistant technologies. Certainly we feel that the current fuel cycle within the United States is proliferation-resistant, but it can be made more so by new designs for the future and by changes in the fuel design. We feel that this is very important to help ensure that our safeguarded nuclear fuel cycle remains unattractive for acquiring nuclear weapons. And really that the long-term sustainability of nuclear power depends on utilizing more fully the energy resources in uranium and thorium. In other words, we're very much in favor of reviewing and reconsidering some of our decisions on reprocessing for the future. And this relates to our last statement, that we feel that it's important to enhance the proliferation resistance both of the closed and the more secure fuel cycles, not to be suppressed in those areas. I want to close with just kind of a review of where we think we need to go in the future and what we think is important. Our bottom line is that a healthy, sustainable domestic nuclear investment is not a cause for proliferation risk, but rather it's a prerequisite. If we're going to have influence in the world community, we need to be a player. We need to be in the game. We need to have our leadership role restored. And we see it as very important to reverse the decline of U.S. technology, and particularly in the education area, and the training area, and thereby our influence in the U.S. And that the continued support of a strong nuclear non-proliferation regime is really vital to our national security. I want to thank you very much for coming out this afternoon. If you have any questions, I'd be glad to answer those. Thank you.
We have time for questions, comments.
You asked me a question?
I'm not asking wrong question. Let me think of one.
You alluded earlier, in an earlier slide, you alluded to the CBA you're talking about Savannah River, so it's 50 TBA fuel. I wonder whether the decision to do the 30 TBA reactor undermines the credibility, or whatever. Has it created a mix of the domestic, military, non-military? That comes to
It causes me problems, and as you may recall, Savannah River worked on a concept involving an accelerator to produce lithium, which was, at the time, the Department of Energy sponsored a competition between that technology and the CLWR technology for nuclear. One of the reasons that we tried to use to advance the accelerator concept is that very thing. I think it is a contradiction. The way you rationalize it is TVA is a semi-government agency. It has been used for part of the development of TVA was to provide power for K-25 when it was operating. So there's some rationalization there, but I think it really was and is a contradiction of our policy of separating the civil program and the space program. And which could be changed, but I don't think that's the case.
You're getting some agreement, on you to say that you also need to okay.
Well, and certainly the reason it was chosen is that it was a cheaper technology. And we couldn't be surprised when we built a $2 billion accelerator. It's hard to sell that.
Any other questions or comments?
Go ahead.
Just a few years ago, the State Department of the Non-Proliferation Concerns were factory divide the mines and we had two concerns. And then continues to be a problem leader of the reactor in Germany being argued about how much fuel. And they're even snapping the word hyper again. Do you think that these few technicians, few high-enriched research reactors really have a role in operation?
I think under the proper controls that compatible with corporation, non-corporation controls. I think under proper controls and agreements, the countries can have it. And IE and IAEA inspections. That would allow you to I don't have any problem with it.
It does lead to some tragic and public great security.
Yes.
But it's quite different from a dual-purpose reactor under the guise of a power reactor, like first that large production facility. So to me, over the years, we've seen the change. The fight been going on for a long time.
And we've received a lot of that high-enriched material in return for reactors and university.
Any other questions or comments? Bob?
The once through fuel cycle is pretty settled at the present time. What would it take to turn this around and bring back the viable option within the context of
Well, I think what it would take is a decision by the administration to put some money back into the R&D efforts. Look at improving aqueous processing, making it more restoration resistant, and also to further development of the pyro technology.
Well, I guess my concerns here are not so much technical as they are political.
Yes.
And we pretty well settled that the industry wants to fuel cycle. And pretty significant change in that, maybe produce upheaval, both politically as well as otherwise.
I think you're right. There's a lot of discussion and plans. That's still the gas to the reactor. Exelon, open the wheel, indicated he's going to do that. I think that's kind of act it's going to take for somebody to decide they're going to do it, or some group of utilities. I don't think it's going to be one utility, although Exelon may do it. But I think it's going to take a group of utilities. We have been trying to advance some ideas regarding the energy park at Savannah River, utilize the infrastructure of the site to help revitalize the industry. And through those discussions, we've talked with a number of utilities and generating companies. And there has been some interest. Interest and raised some proposals along with TA through the Department of Energy. But we may see something happen there. I think in regard to your question, though, with regard to reprocessing, I don't think there's a pressing need. I think we need to be involved in the technology. But right now, reprocessing is not economical. You've got cheap uranium, blood in the market. But in 50 years, that's not the case. We're going to run out of these things. We have to go to another resource. If we continue to use fusion systems, which is fusion, but that's still in front.
Thanks for that clarification.
Of course, we all look forward to fusion, but when I was in school, I said it was 25, 30 years off, and when I talked to my friends involved in fusion, they said it's 25, 30, and 50 years old. So, it's moving out there. Thank you.
Okay.
One last question here. How would you compare the difficulty of bringing back reprocessing as opposed to bringing in starting fuel cycle? See one being favored over the other as a means of getting the uranium sources?
I think that, and this is just my own opinion, thorium really has a extensive potential with it once it's complex. Maybe an opportunity for the future. It's kind of always been out there and it's been talked about a lot. It's really going to take a decision at the utility level to decide which will decide.
One of the concerns is the fact that the
brings in some additional problems. No, which can be overcome.
Yeah, the advantage is really different. There's some arguments on safety. And just that part in, you can take it from the satellite. So it's pretty hard to hide.
I forgot one thing. Go ball!
There you go. I agree with that. Okay.
But I have told my brother, the big country fan who goes to town and he just got in so anything beyond the last Saturday is exciting.
Okay, we do have a few guests here today. You may not know if we have refreshments after all. Our refreshments today, we would like to come down and order some refreshments. Before we adjourn for refreshments, let's express our appreciation again to Dr. Buckner. I encourage everyone to have a safe holiday. Thank you.
Y'all really make good grades, right?
They always do.